Thank you for being with us. We are here to work with if functions in Excel. As it were, the if function involves comparing values or comparing values with a test condition to be met. So the condition is what we call a logical test. So we get a value and compare it with that test condition. If the value meets the condition, the application returns the result as true. If it does not meet the condition, it returns the result as false. Take an example of having marks in percentage and they're being compared with 50 as the pass mark. So a mark that is 50 and above is a pass, while 49 and the rest below 50 is a fail. So in that case, the test condition, we are comparing mark with 50 as a test condition, and we give a result of pass for true and fail for false. So that's an example of comparison, which we shall look at. Meet me on those channels. I present similar content on TikTok. Meet me there. These are my names, Bossa Eric Ronald. I ask you to subscribe, like, and comment on the channel so that it gets kept up. In the comment section, I put quizzes. When you click on the link, you are sent to a quiz, and you are assessed right away after attempting it. So we go on to look at comparison in daily life. We usually compare things so as to take decisions. If I'm buying commodities in the store, I may check, I may want the best, say in a grocery, I may want the best mango being the larger one, depending on how you choose. So the sizes can decide my buying decision, or we can compare people by their gender. If you are moving into a public toilet, you have to check where to go, depending on your gender. If you are awarding hostels, assigning hostels to learners in a mixed college, you can check their gender to know where to direct them. So a comparison decides on on gives results based on a condition. So the people who meet the condition, or the aspect that meets the condition, is the one that passes. So we have comparison situations in life. So we are going on to see the different if functions we have, an if function with one condition, a test condition being one. So, for example, I've given an example of having a pass mark as 50. So the condition in that case is 1. Marks are being compared with 50 to decide whether the mark is a pass or a failure. Then we have what we call the nested if function. The nested if function tests with more than one condition. So in that case, take an example of grading marks. We can have distinctions, credit, pass. So those are varying grades, meaning instead of having one pass mark, they are varying marks to assign grades to a student, to categorize marks into various grades. So each category is a condition. The category of distinction is one condition, category of credit, category of pass and maybe failure. So those are varying conditions, and each condition is put in one function. So here we have what we call the nested if function to represent an if function with multiple conditions, with more than one logical condition. else we have modified if functions. We've seen other functions before, sum, average, count, and the like. They can be embedded with the if function to perform according to a condition, summing according to a condition, counting according to a condition. So, as we go further, we shall get to see that in more episodes. So, have those three, the if function, and then we go on to look at comparison operations. In the first part, we're looking at comparison operations. We take, for example, we are going to compare a value in this column to a value in another column. This value compared with this one. And then we shall have a truth table that gives the results according to the comparison. So when I compare 54 with 50, in the first case, we are checking, is it below 50? Is this value below 50? The value in the blue column is being compared with that in the yellow column. Then we put the expression. The value in this address, the test value is that address. We are using the comparison operators. Less than, the operator for less than, as we know it in the mathematics. We are comparing it with the conditional value. So the conditional value is here in the yellow addresses, while the test value is in the blue addresses, or red for this matter. So this is the conditional value. The test value is rather this one, and this is the conditional value. The conditional value is 50 in all cases. Then the system tells us the needful. And then we go on to compare the rest of the values by replicating the formula, and the system tells us where it is true and false. Is the value, the test condition in the blue address, greater, below the conditional value? Is it below? Then we have true or false depending on the situation. Likewise, we can keep testing the others in a similar way. We can keep testing others. I've reused the function. So, is it above the value, the test value, is it above the conditional value for in this case, which is the opposite of what we did first? Then the system tells us as it were. So then we go on to test the others as well, generate the truth table. Now in this case, we are testing whether the value, the test value is equal to the conditional value. Is it equal to the conditional value? So here we shall see that it's only one condition where it is true, where the test value is equal to the conditional value, and in all others it is false. Likewise, go on to test if the value, the test value is less or equal. Is it less? For where it is less than, or equal to the conditional value. Is it less or equal? For where it is less, it is true. Where it is equal, still it is true, but otherwise it is false. So here it is not less and it is not equal. So it turns out to be false. and then we replicate the rest. Then we go on to do the same, or to test whether the value is greater or equal. Is it greater or equal? The test value, is it greater or equal to the conditional value? And then we get the needful. Then we need to know where it's not equal. Is the conditional value not equal to the test value is not equal to the conditional value. So not equal is expressed with those symbols together, as it were, two symbols, the less than and greater than symbol. They go together. This one means not equal. So true, this is not equal to this, then we shall see. So here is where it is false, because this is equal to this. The test condition is equal to the conditional value. So there we have a truth table generated with the appropriate result. Then, having seen that, we want to see a case where we do away with this column. Instead of having that column with the conditional value or the base value, rather we want to do away with it and have the test value in the function. So there we are going to use the if function, and we shall embed the test value in the if function. This is what we do. We express the if function. And the screen tip tells us about the if function. As we described it earlier, there is a test condition, and if the test condition is met, if true value is given as a result, and false value otherwise. So we have a logical test. This is the function structure. The logical test, the condition, and then there is a true result and a false result otherwise. So here, the test condition here is a value being below 50 is the test. So those that are below 50, values below 50, they evaluate to true, while those that are above 50 it will evaluate to false. So here we put the condition is that value below 50. The value in test, is it below 50? This is the test. Separate it with comma. You have to be careful with the you have to take caution of the punctuation. So we separate the test from the value with a comma, as is displayed here. So the value to be evaluated is what we call a string value, a text. It is in text form. That word true is in text. So here we are going to set the system, instead of giving us true as the result, we are going to set it to customize it to what we need. So here we have to set this application to tell us that those that meet the condition will have the result as below 50. So instead of having true, here we are setting the application to tell us that the result is below 50. Otherwise, those that don't meet the condition, we shall set them to be above 50. Those that are not below 50, they are above 50. Then you close off the parentheses. Sorry for my keyboard. So this is the function syntax. the test condition value must be below 50. So when it is below 50, the true result is set, and what is to be displayed is put in double quotes. While those that don't meet the condition, those values that are above 50, the result is also put here in the formula. So then we go ahead and the system gives the result, and for the rest does the needful. Likewise, continue to populate the truth table by using the same logic. So values above 50, the symbol will have to reflect that. If the value in test value is above 50, then we do the needful. We do the needful and give as required. So values above 50, in this case, what is being tested, and those that are below 50 are the false values that don't meet the condition. So the condition is testing if the test value is above 50. So then okay. Then we go on to see for cases where the value is equal to 50. We also test, as it were, is the value equal, be in test, is it equal to 50? Then we put the resulting condition of true, equal to 50. Otherwise, it's not equal to 50. So the expression goes there, the logical test being the test value being equal to 50 and the result true equal to 50. Otherwise, others are not equal to 50. Then we do the needful and we see is a value that is equal to 50 while others are not. Then can modify still value less or equal to 50. The test value, is it less or equal to 50? So in this case, we are checking whether a value is less or equal to 50. Where it is turns out true, can say yes. For cases where it is less or equal to 50. Less or equal to 50, yes. But otherwise, where it is not equal to 50, so the otherwise condition, those that are below 50 and equal to 50, yes. But those that don't meet the condition should be above 50. Okay, above 50. So here we're having two results. The true result for yes, the value is below 50 or it is equal to 50. Otherwise, it is above 50. So then go on to do the needful and you get the corresponding results. For where it is above 50, we are notified, and where it is equal to 50, yes, and below it is a yes. So that is in that case. And then we have another case for values above. We are going to greater values that are greater or equal to 50. a modification of what we have already done. Values above or greater than 50, greater or equal to 50, yes. But those that are less than 50, we are having below 50 as the result will be returned. So here they are also, the condition is less or equal to 50, and then it's a yes, while otherwise it is below 50, and a needful happens, which happens to be the opposite of what we have done before. Then we have a case where we are checking whether values are not equal to 50. Value not equal to 50. We are checking for values that are not equal to 50. 50 is the test value, which is being embedded in the function, and we are testing. So we have to inspect value is not equal. So the not equal expression goes like that. We have the comparison symbols following one after the other in that fashion. This one means the value in test is not equal to 50, which comes as a logical test, and then confirm it is not equal. For those that meet the condition, we put the result to evaluate to not equal to 50. Let's make it non-equal, while the others, rather, let's have it, those that are not equal, the not equal case, we have it as yes, it's not equal to 50. But otherwise, it is equal to 50. Equal to 50. So the value that evaluates as a true value is not equal to 50. While that evaluates as a false value that does not meet the condition, we say it is equal to 50. So we do the needful, and then we see the result. So in this case, there is one value equal to 50, while others, it is true, they are not equal to 50. So the condition is it equal to 50, not equal to 50? Yes, not equal to 50 in these cases, but here it is equal to 50 where it is otherwise. So this is now our resulting truth table for the various conditions and the results therein. But I want to take note regarding these two. So we are checking if a value is above 50. But because of the condition we have set, the way we have structured the function, here, what is meant to be equal to 50 is supposed to be having equal to 50. 50 is equal to 50 because the 50 is our test condition. The value we are checking if it is equal to 50. And then in the result, we are being told it is below 50. 50 is below 50. This is erroneous. Okay? It comes out erroneous. So we have to put the logic right. Here, we are testing if a value is below 50, and we result with a value 50 is above 50. And here a value is above 50 as we are checking, but here we are being told 50 is below 50. So these two are erroneous according to the logic we have used. So here it means the if function has to be modified to cater for this anomalous question according to the logic we have used. So here, because we are testing for values below 50, then it results that 50 is above 50. So it means we have to modify this function to include another condition. We have only one condition here, but instead we're supposed to have three conditions for values that are above 50, values below 50, and values that are equal to 50. There's one value equal to 50. So we should cater for above, rather greater than, less than, and equal. Three situations. So this if function has to be modified so that it has another condition within it. So this is what we call, or what we discuss as the nested if function, having more than one if condition. So now that we have this condition already, less than 50, and then is its result, we can fix another if condition in the formula in that fashion. Then open the parentheses, then we already have an if condition, so we are adding another within the formula, and then we are doing the needful if the value is equal to 50. We are catering for the value that is equal to 50. Then we do the needful and put equal to 50 as it were. Then the others that don't meet these two conditions are above 50. So we have three cases. We have a value below 50, a value equal to 50, and values above 50. So this is what we call the nested if function, having more than one condition. There's this condition and there's this condition. Now, because we have two opening parentheses, as you can observe, we then must have another closing parenthesis, because parentheses happen in pairs. Since we have parentheses here and corresponding one here from the colors, then the one in black must have a corresponding closing parenthesis, so that there are two parentheses to cater for the two opening parentheses. So then get the result as expected. So here we have those three cases: above, below, and equal to 50. Likewise, the corresponding formula should also be modified by inserting another if function to cater for the value equal to 50, as we have done in the previous case. So here we have value equal to 50, and then we put the corresponding result. So you have to take caution about the punctuation, and the closing parentheses must also be done. So if you close without the closing parenthesis, you get an error message, a typo, and the system is asking to correct you by embedding the required closing parenthesis. Then confirm, and then it gives you the corresponding result. So this one gives a truth table that is perfect. Thanks for being with us. I'm asking you to subscribe, comment, and like so that the channel is running. Then don't forget to work with the quizzes in the comment section.